Okay, shall we begin? Okay, thank you all for coming this morning. Today it's my pleasure to introduce Luca Brocca. He has over 20 years' experience in hydrological applications, including the development of the soil moisture to rain algorithm. And he is, since 2019, the Director of Research at the National Research Council of Italy. Luca, please.
No, yes, okay. These are the slides. It works like this, okay, go back. But in any case, so thank you very much for being here. I would like also to thank the organization for inviting me. And of course, I have to acknowledge my colleagues in my group. I work at the National Research Council. We are it is called Hydrology Group in Perugia, Central Italy. And also I would like to thank you for coming here, because you know, after the dinner, it's always difficult to wake up early. So this is the outline of my presentation today. I will talk about why high resolution for the water cycle. I will talk to you about the satellite products that currently we have for explaining and understanding the water cycle, a few applications. Then I will move at the end for the new high resolution products that currently have been developed for the water cycle, and finishing with the digital twin earth hydrology. So the presentation is quite long with a lot of content. So probably in 45 minutes I will do my best, but probably it will be a rush. I don't know. So but I prepared the slides all basically. All the slides have the same structure. So in the center of the slide, you have a picture showing what is being shown. There is a main message with the same box. And on the right, of course, you will find some references. So if you want more information, you can go there. Then the presentation will be available also on YouTube. And if you have a question, you can ask me. So let's start. Why a high resolution for the water cycle? This is quite well known, but currently we know that natural disasters are occurring over the earth and impacted earth at very small scales. Yeah, in Italy we had the experience last week with the flooding in the Marche region, which impacted an area less than 10 square kilometers, so very localized, very difficult to forecast. But it's not only extreme events like flood, drought, but also the other main impact that we are doing on the earth is related to for instance, to irrigation. The animation on the right shows an area that was a desert in 1984, and now it's a irrigated land. It's a quite huge area, and it happens in many places around worldwide. So actually, we need to develop next generation decision support system working at high resolution, and it is really a very big challenge. It is very particularly important now in these times in which we have big societal and also climate changes. And we believe that Earth observation capabilities can provide a comprehensive view to the reconstruction of the water cycle. And in this presentation, I will give you some ideas about that. So what we have as a satellite product. Let's start from the water cycle. Everybody, probably, I don't know, in Italy, but I guess also elsewhere, we study the water cycle at the primary school, so it's well known. We have precipitation. Actually, typically we start from evaporation from the sea. Then we have precipitation. Precipitation goes to the ground, and then to the river, and then goes back to the sea. And these are the main variables of the water cycle. But actually, the water cycle is not like this anymore, because we are over the earth, and so we are building cities, reservoirs. We change the water cycle for the irrigation, and so understanding and modeling the water cycle is becoming more and more complex. From satellites, we can get a couple of variables that I put here, so most terrestrial water storage, that are quite important, and basically it's not possible to measure this variable over the land in a way that is needed for understanding the water cycle. And so we have started studying all these kind of things. within several projects funded by both European Space Agency, but EUMETSAT, and also from the European Commission. If you look at the red and blue squares, basically they are running projects in our lab. So if you make some counting, there are a lot. And it is because actually the exploitation of remote sensing data for hydrological application is becoming more and more needed, and also many more people are interested, and so that's why we have this kind of number of projects that we are trying to manage. Why satellite products are so important? I have just a couple of examples. This is an example for related to irrigation. The blue line is, soil moisture over the ground, goes up and down depending on the season and on precipitation. If we have irrigation over the summertime, there is a pointer somewhere? Yeah. Of course, soil moisture will be higher. And from satellite data, actually, we can measure this kind of increase with the satellite soil moisture data, similar with the evaporation data. And so basically, by using satellite data, we can see processes that we are not able to model. And so that's why, for instance, some satellite soil moisture or evaporation can help us. The other, quite a normal example is related to the monitoring. The picture here shows that basically, this is the example for river discharge. River discharge is an essential climate variable. Many models need this variable. We need to know the water from the land to the ocean, but it's quite missing. And the ground observation network, they are decreasing. Probably you don't see the label, but it's for different continents. This is the example for Africa. On the left, the gauging station, but actually not all of them are now operational. And on the right, this is what we can get from satellites. So of course, by using satellite data, we can improve our monitoring capabilities. Let's start to what we have now. Actually, my research started 20 years ago, and basically I started working with soil moisture since at the beginning, and still now I'm working on that. Actually, at the beginning, I never thought to work with remote sensing. We do research over a very small area, 1 hectare in central Italy. We measure soil moisture, and we want to understand how soil moisture varies in time and space. We did a kind of study to understand this variability, and then we see that actually this variability can be also tracked with the satellite data. And so we started using satellite data within hydrological modeling for flood forecasting, but also for landslide. I will give you an example later. Then in 2014, we developed this approach for estimating precipitation from space by using soil moisture data that is quite different from the classical approaches. And we have used the same approach for irrigation, and that's why I will talk to you about also this variable. And finally, now we are moving to the use. Actually, we are not a developer of remote sensing product, to the use of high resolution remote sensing product for the different component of the water cycle. So soil moisture starts in November 1978. It's probably one of the most robust variables that we have from space over land, except for the vegetation. And actually, I started also my life in November 1978. So basically, you have soil moisture data since I was born, and already when I was young, I was exploring soil moisture. And that's why probably this is my job, I don't know. Now we have different operational soil moisture products. So actually, we have soil moisture data. They are operationally available. There are 3 examples here in the Copernicus, long-term, high resolution, and this is high resolution, 1 kilometer. This is from 2007 to the present by using ASCA soil moisture. Another kind of products we have also under the HSAF projects from EUMETSAT, and again here also we have different kind of products. All of them are operationally available in real time, long term. For instance, we have a good zone soil moisture from 1992 to now, so you can study climate. So we have a lot of options. Of course, depending on your application, you can select the ones that you prefer. And then what else? Precipitation. Precipitation, of course, is the main driver of the water cycle. Again, here we have from NASA and JAXA, we have the GPM mission. But then from EUMETSAT, of course, we have, again, we have different kind of precipitation products in real time. This is, for instance, an example for a flood events not last week, but 2 weeks ago, because after a drought in Italy now we are going to have flood events, and another one is expected at the end of this week. And on the right here is an example of the products that we have developed under the HSAF projects, in which basically we integrate, I will talk bottom-up and top-down approach. Yeah, this is what I'm talking about. Actually, in 2014, we have developed this approach that is called SM terrain, that basically is a different approach for estimating precipitation from space. Instead of looking at the clouds in a top-down approach, we look at the ground, and basically by tracking the soil moisture variation in time, you can track also precipitation variability. And for instance, this is an example of, on the top, you have our products. In the bottom, you have data from ground station on the monthly scale, and you can see quite a nice agreement. But you can now, under also a project with EUMETSAT, we have developed the long-term data sets that it's going to be operationally available in the HSAF projects. So it is going to be an HSAF operational product. This is an animation of the monthly precipitation. The data are daily resolution, 1 kilometer. They are available here for free, and you can use for any kind of application, if you like. Of course, data are only over land because we get soil moisture from, we get precipitation from soil moisture. And of course, we have also other potential ways of getting the data. For instance, this was done in a collaboration with some colleagues in a company in Italy. We have put the data in a platform, and from this platform, you can easily download the data and also, I don't know, extract the data for a single point. I will talk also actually the possibility to make the user aware, and also to use your data as easy as possible is one of probably the main targets that we should focus on. Then irrigation, and basically the same principle. If you are able to track soil moisture, this is soil moisture data from in situ data. You can also be able to track not only precipitation, but also irrigation. This is with in situ observation in northern Italy for an experimental farm. And this time series shows, in the bottom, shows precipitation and irrigation bar. And the red line is what we get from soil moisture. And so basically, if you have good soil moisture observation, you are able to track not only precipitation, but also irrigation. And irrigation in many parts of the world is one of the most important unknown in the water cycle, because it's changing the water cycle and also the energy cycle. For instance, also the boundary layer, it's really a huge impact, it's having a huge impact on many components of the water cycle, and actually we don't have this kind of observation. And we can get from space. We started more or less 2018, 4 years ago. This study was done in Iran, close to Urmia Lake. Urmia Lake is a lake that is disappearing. Now they are trying to make it appear again, but because it is a lot of irrigation on the top of the lake. And here again, we have used satellite soil moisture data, and if you look just at the bottom, and the gray area is the observed irrigation data that they have in that field, and the blue line is what we get from satellites. We have started also, I won also a Copernicus competition for that. And now with the European Space Agency, we have these Irrigation Plus projects, in which, because irrigation is occurring at a very small scale, and so using coarse resolution data is a challenge in many parts of the world. But now with Sentinel data, we can also track irrigation at high resolution, and this animation shows 1 kilometer irrigation estimates over the Po Valley. This is an example for Spain. For instance, now we have a data set for the northern Italy and for the Ebro Basin in Spain. And these data sets also will be made available quite soon. Then I talk about soil moisture, precipitation, irrigation, and river discharge. Of course, we have also evaporation that is an important component of the water cycle, but it's not our, for our group. We do also research on evaporation, but in collaboration with other partners. So the last variable that I will talk about is river discharge. There are different approaches. This is on the left, you can see the approach based on radar altimetry and near-infrared sensors. And on the right, we have developed a conceptual hydrological model exploiting satellite precipitation, soil moisture, and terrestrial water storage for getting runoff and river discharge. I will give you more examples, but something that can be done very easily. You can look, these are several locations that you can see here worldwide. And the blue line are observation data. And the red line is the observation, in this case, obtained from of river discharge from radar altimetry. And you can, you probably don't see the time label, but by using satellite data, we can extend very nicely time series of river discharge, because for most of the, for instance, here the stations start end at, I'm not able to see, I have to, 9080. But for instance, here you have data from 1950 to 2000 with the in-situ observation, then you can extend, and so now we have more than 50 years of river discharge data, and so we can, here we have investigated the long-term trend, and for instance, in Africa it's very interesting because in the 1970 to 2000 we have a decreasing trend over the Sahel and South Africa, and it's the opposite in the recent 30 years periods. And so actually with this data, we can really study long-term climate applications. Other applications, what are the different applications that we are managing? One of the main applications for with satellite precipitation data is the extreme events monitoring. This is what we have done and what we are doing and what we will do in the HSAF project. For instance, on the left, you can see the animation of the cyclone Idai in Madagascar. And we track the occurrence of the precipitation. In the middle, you can see also the accumulated precipitation. And on the left, on the right, you see the current products that we have available every day. Actually, we have different products. This is one of the products, but we have also high-resolution 5-kilometer real-time precipitation products from EUMETSAT that will be improved, of course, with the launch of next-generation MTG. And so we can track, and a very nice, a very good, not nice, example on what we can do with satellite soil moisture and precipitation together is this animation. You should be able to see on the bottom, from brown to green, the soil moisture observation. The color bar is on the left, and on the right, you should see on the top precipitation occurring for the Central Europe flood events occurred last year. And you can easily see that this is from the beginning of July to the end of July. No. And you can easily see that we are now 12th of July. 12th of July is the time of the flooding, but the flooding is occurred not really for an extreme precipitation event, but for a long-term precipitation that makes the soil completely saturated. And on 12th of July, rainfall occurred over saturated soil, and that's why the impact was catastrophic. And if you look at this year, the same months, basically the maps that were green, now they are completely brown. And so actually in the same months of the year, we have really a changing of what is happening, extreme events on both sides. With satellite data, we can track. We can track and we can understand what happened and what can happen, because we can use this data for sure. For instance, for alerting, for giving alert. Of course, if the soil is going to be saturated, a small amount of precipitation can have devastating or catastrophic impacts. And this is, for instance, what we have done and we are doing also by exploiting satellite precipitation data, because satellite precipitation data are available everywhere. Actually, my main field was the flood prediction. I'm an hydrologist, and so my main field was to predict floods, to predict this kind of picture. So the gray area is observation, and we want to predict as best as possible this time series. But with satellite data now, we are able to make these kind of things everywhere. Basically, each dot here is a location over Europe, Africa, and Brazil. Of course, this is done with several colleagues, but now we have, for instance, tested satellite precipitation data for more than 2,000 catchments if I at the beginning of my career, when you do this kind of analysis for 5 catchments, is a big analysis. Now we can do with satellite data with more than 2,000 catchments, and the color of the dots, blue is good. You can also understand the quality of the data, and it's quite impressive what we can do now with satellite precipitation for hydrology. Floods, then drought. Drought, of course, in Europe has become a big issue. We started in 2017 because in 2017 we have we have droughts in central Italy. We have a problem in Rome, and so we started studying droughts. And at that time, for instance, we can see what is very important with satellite data, that you have a picture over in time and space. So you can track, for instance, the thermostat difference between Italy and Poland. Poland is here. You can track the difference between 2017 here and 1998. And so you have a global picture and consistent in time and space. And this is very important. The quality can be some issues, some errors. Sometimes satellite data can be wrong. But having a long-term and global coverage is really very important for drought monitoring. Probably drought monitoring is the most well-established application that we can do now with satellite observation. Here, for instance, we can see that at that time, Southern Europe is drying and Northern Europe is wetting. And then after that time, the last 5 years, we have drought in Central Europe every year, more or less. And so actually, climate is really challenging us. And this year was really a nightmare in northern Italy, because this is very nice, because actually I gave quite a number of interviews with the Italian media. Actually, this is not my job, but they know that we are using satellite data for monitoring the water cycle, and then by using only satellite data, we can monitor precipitation. This is, for instance, precipitation anomaly for the first 4 months of the year, always red, which means less precipitation than normal. This is with satellite thermostat data, again red, and this is time series. You can see that the year 2022, already in March, we were in drought condition. Snow, we can monitor snow cover with different approaches, and again, the red line is on the bottom of the time series for the last 20 years. So we miss snow, we miss precipitation, so we miss thermostat. We can also track river discharge. And so by using only satellite data, you can track the different components of the water cycle, and you can really have an understanding of what's happening. Sometimes we study drought by using only precipitation, because precipitation is available since 80s. But now with satellite data, really we can track all the components, and it's really a huge step forward for understanding what's happening. For instance, this year, the problem in northern Italy was the missing snow. Missing snow, then missing precipitation, missing snow, and then, of course, we had the water scarcity issue over the summer periods. But the problem started in January, February, March, and it's not starting in July, for sure. And last application for runoff estimation, we had the project with European Space Agency. We exploit satellite precipitation, thermostat, and terrestrial water storage for estimating global runoff. We did for 5 big catchments worldwide, and for each of them from 2003 to 2017. Now we have extended to 2021. We are able to track daily runoff every day throughout the catchments with the resolution of 20 kilometers. The idea is that actually this map should be filled everywhere. It's just a matter of computation and and parameterization, but we can do this. And this can be really an added value if you want to know the water from the land to the ocean. That is a quite big, important challenge for also for the numerical weather prediction community. And all this analysis that I have shown here was done with coast resolution data. Coast resolution to me means from 10 to 20 kilometers. But really now we are in a turning point, because actually we are now going at 1 kilometer for many variables. And getting the data at 1 kilometer is really a huge advance and a big challenge. give you some example. This is, for instance, Sentinel-1, soil moisture data. This is an area in Sardinia. This area, agricultural area, many different fields. And if you think at 10-kilometer products, actually this is less than 1 pixel. But now with high resolution data, we can track soil moisture variation field by field. And it means that we can track soil moisture variation field by field, means also that, for instance, if one farmer irrigates and the other no, we can track this. Of course, the quality of the data should be checked, but at least we have observation field by field that can be used for agricultural applications. And this is occurring basically since 2016, 2017 that we started having this kind of data. For river discharge, for instance, we have started our activities by using, for near-infrared data, by using MODIS data. This is an image showing actually the Po River basin. You can see it. And now we are doing the same with the Sentinel-2 observation. And of course, you can see many more things. It was a study just published a couple of weeks ago from one of my colleagues. And actually with the Sentinel-2, we are able to track water inside the river, in the barren, in the coastal area, vegetation. And so actually this is the Po River, so actually it's quite a small river with respect to, I don't know, the Danube or the Rhine or the Amazon, but for these smaller rivers, we can really start to see how much we are able to measure river discharge from space. And this is what we have done in this paper. Then precipitation. Precipitation is, again, is very important, and we have started to make in the framework of digital twin Earth. We are starting exploiting Sentinel-1 observation, ASCAT observation from METOP, and hoping also with the new SCA sensor, actually resolution will be higher. With these two observations, basically, if you want high resolution data from space, by exploiting soil moisture data, you can get high resolution observation. Then we integrate also with the GPM, because GPM has high temporal resolution. And so at the end of the day, we come up with a 1 kilometer, 1 hour precipitation product obtained only from satellite observation. This was done for the Po River basin. Now we are extending over the full Mediterranean area. Step by step, we will go to the Europe and blah, blah, blah. And for instance, here it is an example of the performance of these products against ground meteorological radar data, 1 kilometer resolution. And the yellow bar is the product that we have developed, and the other bars is the parent products, so the products that we have used that we have integrated together. And so you can easily see that an improvement also in terms of accuracy. And here the animation shows an example for a couple of days of a big rainfall events. And so now we have high resolution observation for precipitation. We had a project for the Po River basin, so you can see several figures for the Po River basin in northern Italy. We have high resolution soil moisture, precipitation. Some of our colleagues is developing high resolution evaporation data. This is what we had 3 years ago, 4 years ago. This is what we have now. And of course, there is the challenge is how to assess these products, because we don't have 1 kilometer observation for any kind of these variables, and how to use them. And then if you go, for instance, over a large area, how to tackle all this data that we are now producing. And one nice example is here again, irrigation data. Actually, we have these maps. They weekly irrigation water use from space, but we have no idea. We have done, of course, some validation at 3 points in the Po Valley. Then by using satellite data, we can extend everywhere, but we have no idea the quality of the data, because we have no ground observation that can be used for assessing this kind of data. And the idea is to indirectly assess the products by using this data as input into the modeling, and to actually to see what is the impact on the water cycle. But it's really something completely new. And here again, to make people aware of the products, we have a platform here in which we can explore the data, but also we have also some use cases. I have a slide also later. But this is very nice. For instance, this is precipitation maps for 1 day. And this is soil moisture. And you can easily see the track, the footprint of precipitation over the ground. And it happens at high resolution, also over the valley. And so actually, high resolution data, actually, you can really see some new features that with coarse resolution data, of course, it was not possible. And it goes to the last part of the talk. What is this digital twin Earth hydrology is a project that we are running with the European Space Agency that now we have also an evolution. This is what we have done for the Po River Basin. And so basically at the end, we have integrated high resolution products that I have shown you before in high resolution and advanced hydrological modeling. And so by integrating all of them, you can then, we have performed different application for landslide risk, flood risk, and irrigation. And I have a nice video that was developed by an American company for us. And this is, again, the example of the Po River Basin. You can see here the Po River. Now you have, for instance, satellite data of soil moisture. Of course, you have only some track. If you integrate with modeling, you are able to have distributed and continuous soil moisture time series over time. But you don't have only soil moisture. You have also evaporation, precipitation, all together. And for instance, if you use precipitation and evaporation at high resolution into the modeling, then you get also river discharge at 1 kilometer distributed throughout the basin. So now we have, for instance, here this for the Po River Basin. We are going to make the same for the full Mediterranean area in another project with the European Space Agency. And with this data cube, we can explore many things. We have done something. We have done application for irrigation, flood, and landslides. But you can imagine that with this kind of new observation, you can really start to look at many different applications. For instance, fire monitoring. After fire monitoring, what is happening is something very interesting. And these 3 videos shows you the high resolution application. For instance, this is a very small, on the top left, very small area in northern Italy, where we have a flooding. And so with this data, we were able also to integrate with hydraulic modeling. And so we are able to study the flooding. This animation was done with a resolution of few meters. So actually, if you want to make flood analysis, actually you have to go even higher resolution. But you can integrate all the data that we have for doing this. On the top right, it's a green to red map showing the landslide risk over time, day by day, for an area, a small area over the Po River Basin. In the bottom, it was the animation for the irrigation data for a small area, but now we have the irrigation data everywhere in the Po River Basin. And of course, we have used this product again for flood prediction. You know, at the beginning I told, before in previous slide, we did the analysis with satellite precipitation for many basins throughout the world, and with different accuracy. Now we have done the same for the Po River Basin. Po River Basin is a very well gauged area. We have more than 600 stations, so precipitation is monitored very well. And the plot on the bottom right shows you an efficiency index. One is perfect. On the left, you have what we get from observation. So quite good, very good results. Kg equal to 0.8 means that you can see here, probably you can see, but you are able to track very well river discharge in different stations throughout the basin. Each red dot is a station where we tested the model. And here there are different satellite precipitation products, the integration between them. And also here, this one is the products at high resolution that we have just developed. And actually, we get performance similar to what we get with the gauge observation, but it's not, I don't know, like in Northern Africa, where we have, for this kind of basin, you can have 3 ring gauge. Here we have 600 ring gauge. So basically, with satellite precipitation, we are really approaching the quality of gauge observation. And of course, we can get this data everywhere. Drought is the hot topic this year. This is what, we have done a lot with satellite soil moisture data. With ASCAT soil moisture, actually, you are really able to track drought everywhere in Italy, in Europe, with very nice examples. And for instance, these are the maps from June to August this year. red, actually you can really see that, yeah, this was the area most impacted by drought in Italy, and it's really very, very red in the satellite observation from ASCAT. But now we have Sentinel-1, so actually you can really see the difference in the resolution of the two. And this is for June, and with Sentinel-1, really we can track sun moisture not only over the big plain, but here you have the valley along the alpine area, so very narrow valley. And so with this product, we can really see sun moisture variation over the narrow valley. And so really now, for instance, we are trying to use this product to monitor drought over the alpine area. And if you think about that, 3 or 4 years ago, it was simply not possible. Now we have a long-time time series also from Sentinel-1, and so we can start to make this kind of application. And we can also study, for instance, irrigation water use over the alpine area. That is really amazing if you imagine to do these kind of things a few years ago. And, but there is also a problem, because now we have high-resolution data, for instance, irrigation water use. As I told you before, we have this data, but we don't know actually how to validate. But then people started contacting us. They have these 3 fields. Each dot is 1 measurement from satellites, and they want irrigation water use for just this field, and this field, few square kilometers each of them, and they want separated observation, and we have from space, but really to tell them that these data are accurate or whatever, it's really a challenge. But if you go on the ground, people want this kind of information. So it's really challenging, but this is something that we can start to understand where we are. And that's why with this, and now also again with the evolution of the Digital Twin Earth project, we are developing what-if scenario for flood forecastings. For instance, now we have high resolution soil moisture, precipitation, and also snow. And we have developed an approach for for developing a scenario of different different flood scenario. This is the time series of river discharge over time. So you can imagine, you know from the meteorological forecaster that tomorrow we will have 100 millimeters of precipitation. By using this simple approach, based on satellite observation, you can have an idea of what can occur in the next days with 100 millimeters of rainfall can occur. And for instance, it is already in this platform. You can go there. You can see because the application was already there. It should be refined, but it's already there. And it's something that we want to show also to the stakeholder to let them understand what we can do with satellite data for flood forecasting scenario. More challenging is water resource management scenario, because in that case, we don't have only the climate, but so we have initial condition that is important, the climate scenario, but here we have anthropogenic scenario. So for instance, how much irrigation we want to use and how much we want to make to have the reservoir water level. This is what actually happening this year in northern Italy. People contacted me and telling me what they are doing to manage water over the Po Valley. And with this kind of advanced integration between satellite observation and modeling, we can actually develop such kind of scenario by tuning the different, let's say, climate, anthropogenic condition and initial condition. You can have an understanding of the impact in terms of, for instance, water volume for the different uses distributed in space and time. This is something that we are working on, but it's something that is feasible. It's not easy to manage all the different information, but integrating different observation from space and with modeling, we can start doing these kind of things. And this is, again, the platform that we have developed there. And so, for instance, now you can see here is the what-if scenario for flood forecasting. Here we will have, for the full Mediterranean, a long-term climatology, no long-term, a 5-year climatology of the different variables of the water cycles and moisture, precipitation, river discharge, evaporation that I've shown you before in the last 6 years. And we want to show anomalies, and you can have anomalies pixel by pixel at 1 kilometer scale. And here on the right, for instance, together with, in collaboration with Sea Research Foundation, we also did an analysis of the Medicae in Apollo that occurred in southern Italy last October. And we have high-resolution data of the different variables, but then, of course, we can do also flood, high-resolution flood modeling. And again, this can be done by exploiting all the observation that we have now from space. Last but not least, training. It's not training, it's to me, at the beginning was not so important because actually I work at CNR, not at the university, but and now I understood that training is probably one of the most important components that we should develop in the next year, because we have the data are there, but most of the users, they are not aware of the data first. If they are aware, then they don't know what to see from the data, how to use the data, because actually the hydrology users are typically, they typically use ground observation, and so they are not used to manage this kind of observation. And so we have started different kind of training, for instance, here for the Italian civil protection, international school with the European Space Agency and also with the HSAF. And this kind of training is important, but then of course we have also to make a lot of user support. And it goes to the last slides that basically take home message from this presentation today. We have very recently, we have high resolution data for hydrology from space at high resolution. The problem is that actually we have to still to understand the quality of these products. But, and you note that it's not only the spatial resolution that is important, but also the temporal resolution, because if they don't go together, basically high resolution data can be unuseful. For instance, if you think to flash flood occurrence, you need, for flash flood, you need hourly data. And so actually there is a big opportunity to understand what we can do and which kind of application in science and real-world application we can manage. Human impact, to me, the human impact on the water cycle is really the most beautiful and complex challenge that we have to face. With satellite data, as I showed at the beginning, we can track some of the impact of the human on the water cycle, and this can be done only with satellite data, because with it's unfeasible to think, for instance, to know the irrigation water use for a big for a plain like the Po Valley, in which I don't know how many farmers they are and how complex it is. With satellite data, it's the only option that we have, and so actually it's a kind of a must to understand how to exploit such data for addressing this observation. And yeah, as it is written here, modeling human behavior is much more difficult than modeling physical processes, because actually we as humans, we have basically a random behavior. And last but not least, again, data availability from space is not an issue anymore. The data are there and we can use them. But training and what it's called capacity building is really important, and it's not only training, like, I don't know, I do a webinar, or a course or a school, but you have also to exploit the data to facilitate the user for the data access, data reading, data understanding, and it's not only school and lecture, but also on-site training. One probably very important thing is to go to the meteorological or hydrological services, go there, stay there for 1 week to show what we have from space, what they can do, and then step by step to build together the exploitation of this data for the application. That's it from my side. Thank you very much for your attention.
Thank you, Luca. We have time for some questions, if any. Okay.
Thanks a lot, Luca, for this very nice presentation. Also, the work you are doing for EUMETSAT at the hydrological staff, quite impressive. And we have seen several potential products now from flood monitoring, and also with a certain capacity to use the monitoring for warnings. We have seen potential for high resolution data to have I don't know, all the aspects into the river's discharge and how sediments can go into the river discharge. So there are potentially a lot of important application in our society. And of course, training you mentioned, this is a barrier, and then, training takes a lot of time to, let's say, to bring new products to the operational side. And maybe we don't have that long time, so it's important, but we need also to accelerate this process. So and you have here WMO, other organizations, what could we do to help, let's say, to accelerate this uptake of all these products into an operational community, if you have a bit of ideas on this area?
No, first point to me is that it is working now? I don't know. First point to me is that actually we should stop to develop new products. Yeah, we have products, of course, we can improve them, but probably, if you have a project with EUMETSAT, of course, the main target is to develop remote sensing products. But for instance, in the current phase of hydrology stuff, we started a new working package, user support, because we really believe that it's really the way to go. The data are there, we have to make people aware and make people use. My experience in exploiting this kind of data with agencies is to develop together with them, to co-develop the use of the exploitation of the data in their application. If you co-develop with them and they start using day by day, then they start to trust on what we are doing more than you. Because for instance, every day, for instance, I have experience for the flood and landslide alert. Every day they have to see what's happening, and so every day they look at the data. I'm not doing myself. Nobody of us, I guess. Look, they develop, I don't know, a precipitation product for 20 years, but then you don't see every day the products. But they do every day, and so if they start doing every day, they start getting understanding and trusting on the approach. Of course, there are some also error limitation, and then we can talk about that. But the main point to me is to make them aware of the data and to make them, to give them the trust of what they are doing. And if you do together, it works. If you develop an application, also very nice web application, and you give to them, they will never use. This is also the same for when you develop, I don't know, new model. It's not only a problem of satellite data. It's a kind of, let's say, but I can do the same. If somebody come to me and say, okay, you have to use this, probably 1 day, 2 days, and then I will stop.
Yeah, Luca, also add my thanks to your very comprehensive presentation about remote sensing and hydrology. We, WMO, realized that the in situ ground-based measurement declined in the past 20, 30 years. We still have a struggle in that, how to maintain a baseline. It's a ground network. As you indicate that whatever satellite technology, you need a ground truth for validation. So this is maybe a challenge for WMO because we are responsible for coordinating global operational hydrology. So this is so would like to hear from you that how we can help the global community to have a baseline in situ observation to support satellite. I see quite promising that now more and more advanced satellite technology can help a lot for the global hydrology. It's a business. Second, the technical part, I still not quite understand that even with the high, for example, altimetry or whatever other high images data, what are the current accuracy uncertainty compared to the ground segment for the discharge, for example. So this is we need to really see, give a signal to measurement community how much difference, how we expect the further improvement of measurement if you do not meet your accuracy requirements and you just say, we can make it, but not good enough. So this is maybe another challenge. Third one, I did not hear a lot about the coupling of atmospheric No, weather model with a hydrological model, because we have several cases at the country level that meteorological people believe that their model accuracy are good enough, but hydrological did not make a good prediction for flood, lead a big disaster. So, for example, in the past 2-year case in Germany, it lead many people died. So this is the coupling of the two community issues. So sorry for long question. Yeah, thank you.
Yeah, okay, reply can be long, and actually we can discuss also later if you want. But for the first point, of course, I don't think that satellite data alone are the holy grail. Of course, we still need ground observation. And in particular, I have shown you different variables of the water cycle: precipitation, evaporation, soil moisture. Soil moisture to me is the most advanced one. If you think about river discharge, we are very far from getting river discharge from space with enough accuracy and coverage. And we strongly need ground observation because, from space you can get, observation of the water level, but then you need to know the water velocity, and nobody tell you. You need to know the geometry of the river, that from space is not possible. So actually, we can do something, but we need in situ observation or some modeling based on ground observation to calibrate. And so really, we can't imagine that only from satellite data we will have a global river discharge with enough accuracy and, let's say, robustness that can be used everywhere. So of course, we need ground observation. What we can do with satellite data, we can, for instance, we can calibrate something over the past and use it for the future, so we can increase the coverage, but of course, the ground observation should be still there. And for instance, for some of the projects that we have, one project that we have with ESA, we are developing together with them a kind of fiducial reference network worldwide that is a network of ground stations that we can use to measure river discharge from in the ground, and to use like a fiducial reference measurements network to calibrate the algorithm that we get from satellite data. This is something that, for instance, we are doing also with the European Space Agency, that they are also funding this kind of activities. And first point, second point. So actually, we still different variable of the water. Evaporation is in the same as river discharge. It's very complex. We have the data, but we need to assess them. Last point, very interesting. Meteorological and hydrological communities are not the same. Every time when two people met, the guilt is the other one. It's my model is working for sure. It's the problem of the other people. We had the problem last week. Last week, yes, last week in the Marche region. There was big flood events occurred over very dry soil. Typical hydrological model, they work that if the soil is saturated, you have a flooding, otherwise not. But if you have long-term drought, we know from hydrology that the soil is, we have crust soil, and so runoff, the water can't infiltrate into the soil. And so it's like very dry soil is like very wet soil. But if you put in a mathematical equation, you put, monodical equation, and so you are not modeling this kind of approach. And so we have, of course, we had huge rainfall events, and so probably, but our hydrological model, all of the model that we have, they are not able to simulate floods. And so that's at the end what is my main concern related to all the activities related to digital twin now, because we are telling to people that we are going to make advanced modeling system at 1 kilometer resolution, and so stakeholders expect that they have information pixel by pixel, but at that resolution, everything is very complex. Hydrology is very complex. It's not just the problem of for instance, hydrologists are typical to work at very small scale. And we know all the problems at very small scale that can happen. If you average at 20 kilometer scale, more or less you're there. But actually, stakeholder wants the information at 1 kilometer scale, even less. And giving this information at high resolution really needs a lot of new understanding from from the scientific point of view, and also really needs a very strong coupling between communities. It's not only meteorological and hydrological communities, but also, for instance, IT experts. Now we have to manage data that we can't manage anymore in our lab. You should have some cloud computing facility. You should go to IT expert and to make them to collaborate with them. Otherwise, you can't do this. And really, it needs a community efforts to really, if you want really to make prediction at high resolution and large scale.
Okay, thank you. Hello? Okay. Yeah, finally, congratulations for your great achievement. And offline and WMO, me and my satellite chief, Ken, will approach you to strengthen the collaboration, because I agree with you that your product should be promoted to the world standard, which WMO is very keen that to make progress on the standardization.
Probably we are going to write a small proposal for the deadline that we have for next week, something like this.
Yeah.
But
okay.
Of course we can do also much
Thank
more.
you, thank you.
Okay. If there are no more questions, then I think we should thank Luca again for. Oh, sorry. Terribly sorry.
Just to say a few words about evapotranspiration. I'm from the Meteorological Institute of Belgium and also in charge of evapotranspiration in the Landsaf. So I would like just to mention the research effort and the products that are developed about evapotranspiration in the frame of EUMETSAT Landsaf. So currently, we have an operational product derived from Meteosat second generation. So it's available with a 3x3 kilometer spatial resolution at subsatellite points. So over the Po region, it could be 3x5 kilometers. So already a slightly better than the 25 kilometer you mentioned in your presentation. And currently we have operational products since a few years, and we will issue very shortly a data set from 2004. In the CMSAF, in which we are contributing as well, we are also working on a data set that will be produced from, derived from Meteosat first generation with, unfortunately, lower spatial resolution, maybe around between 5 and 10 kilometers. So we continue research to improve our products. So, and also to mention that we use the HSAF sound moisture to derive our products. So we'll be glad to interact and collaborate if possible, trying to go to a higher spatial resolution in the future. Thank you.
Of course, yeah, we are here for collaboration, but yeah, the point is here. You know, we have already, I don't know how many products for evaporation. If you are a user, you get lost. That's the point. I'm a user, so I have the perspective of the user, not of the developer. But really, we should make people aware and people use, because otherwise they get lost. We have, yeah, really, we have a lot of observation from space that we can use. But please try to make them used, not just in the archive. Okay, that's the.
Okay, so as there are no more questions now, let's please thank Luca for this very interesting and comprehensive talk, and go for coffee.